Hello, I'm Albert. Today I'll be going over the 2024 AP Statistics FRQ. I actually took this FRQ, so I'll be sharing my proposed solutions. Now, these are not the official answers, but I'll try my best to be as accurate as possible. So let's just go ahead to my response for FRQ number 1. I won't be reading the whole question, so pause the video if you want to read through it. So for FRQ question number 1, I structured my response as state, plan, do, conclude. You don't need to structure it like this way, but it's a good way to organize your response, especially for these inference procedures. So in the state, we talk about our hypothesis. So the null hypothesis is that P1 minus P2 equals 0, and our alternate hypothesis is P1 minus P2 is not equal to 0. And we need to define what P1 and P2 is. So P1 is the true proportion of all exercise center members ages 18 to 55 years who would be interested in taking online fitness classes. And P2 is the true proportion of all exercise center members ages 56 years and older who would be interested in taking online fitness classes at the significance level of 0.05. So you need to say, so moving on to the plan section, we need to state specifically what test we're doing. We are doing a two-sample z-test for P1 minus P2. And then we also need to make sure that we meet all the conditions to conduct this test. The first condition is random. And as you see in the problem, it says that they obtained random samples. So you simply state that. So exercise center members ages 18 to 55 years were randomly selected, and exercise center members ages 56 years and older were randomly selected. So we meet that condition. The next condition is the 10% condition. So assume N1. So N1 is the sample size of exercise center members ages 18 to 55, and we collected 170 of them. And that is less than 10% of all exercise center members ages 18 to 55. And again, assume N2, which is basically the sample size of our exercise center members ages 56 and older, and we collected 230 of them, and assume that is less than 10% of all exercise center members ages 56 and older. And we can assume that because in the beginning of the problem, they say a large exercise center with several thousand members. So we can assume that the 10% condition is met, and that basically all the observations are independent. The last condition is the large counts. And before we do the large counts, we need to calculate this value right here. And we are assuming that P1 equals P2. We stated that in our null hypothesis that P1 minus P2 equals 0, which is another way to say P1 equals P2. And since we're assuming this, we have to calculate this value that I boxed here. We need to use this formula. Now going back to the problem, right here, this paragraph right here. So x1 would be 51, x2 would be 79, n1 would be 170, and n2 would be 230. Plug in those values, and we get 0.325. In order to check the large counts condition, we can first multiply n1 by 0.325, n1 being 170, and that will give us 55.25. Then we multiply n1, which is 170, by 1 minus 0.325, and that gives us 114.75. Moving on, we multiply n2, which is 230, by 0.325, and that gives us 74.75. And we also multiply n2 by 1 minus 0.325, and that gives us 155.25. So we can see that the four values that we calculated here are all greater or equal to 10. In other words, the number of successes and failures are at least 10. And because they are all at least 10, we can say that the large counts condition is met, and that basically the sampling distributions are all approximately normal. Since we met all these conditions, we can move on and actually do the test. So first, I did the sample proportions. I calculated the sample proportions which they've given us, and I made them into decimal form, so 0.3 and 0.343. Plugged in these values up here into this equation to calculate z-test statistic, and also you can see that I used the value 0.325 that we calculate here, and 1 minus 0.325. And then the bottom here, 170 is N1 and then 230 is N2. Ultimately, this should give us negative 0.908. You can plug in this z-test statistic into our normal CDF function, where the minimum is negative 99999, max is negative 0.908, mean is 0, and standard deviation is 1. And we multiply by 2. And the reason why we multiply by 2 is because we are simply looking if there's any difference. So you can see in the alternate hypothesis, we said not equal to 0. And because we are just simply looking if there is any difference, this is a two-tailed test. So we multiply our normal CDF function here by 2, and that should give us 0.364. That is our p-value. And so then we can conclude, since p-value equals 0.364 is greater than the alpha value 0.05, the null hypothesis is not rejected. There is no convincing evidence that the true proportion of exercise center members ages 18 to 55 who be interested in taking online fitness classes is different from the true proportion of exercise center members ages 56 and older who've been interested in taking online fitness classes. And that's it for FRQ question number 1. Let's go ahead into FRQ question number 2. Again, you can pause the video if you want to read the whole question, but let's dive into my response for question 2, part A. So here are my segmented bar graphs, and I plotted the relative frequency using for elementary school using what they have given us. As you see here in the problem, the relative frequencies for elementary school were 0.5 for small bottles, 0.3 for medium bottles, and 0.2 for large bottles. As you can see here, I put this on to the segmented bar graphs, and again, it aligns with the key that they gave us here. And then for middle school, I just divided the bar into thirds. And the reason I did that is because in the problem, it said for the middle school students, the proportion of bottles sold was equal for all three sizes. And for part B, it's asking if the elementary school administrator's conclusion that elementary school students sold more small bottles than middle school students, if that conclusion is correct. And my response is that the conclusion is actually incorrect because the total number of bottles sold by middle school students times the relative frequency of small bottles is always greater than the total number of bottles sold by the elementary school students times the relative frequency of small bottles sold. And that's because since the middle school sold 3 times more bottle in total than the elementary school. So it might be kind of difficult to understand this, but so I just gave you an example here. So let's say the elementary school students sold a total of 10 bottles. So 10 times the relative frequency of small bottles, which is 0.5, that gives us 5 small bottles. Now, for the middle school, we can say that they sold 30 bottles because in the question they said that middle school sold 3 times more bottles in total than elementary school students. So 30 times the relative frequency for small bottles, which is 0.33333, and then that should give us 10. And you can see, or 10 small bottles, and so 10 is greater than 5. So therefore, the administrator's conclusion is incorrect. Now moving on to this question, we're interpreting a mosaic plot. And so my response for this question is that high school A sold a greater proportion of large bottles because the relative frequency of large bottles sold by high school A is 0.7, as you can see here, which is greater than the relative frequency of large bottles sold by school B, which is 0.6. And you can see that, yeah, 0.6. And for this question, which of the two high schools sold a greater number of large bottles? My response is that high school B sold a greater number of large bottles because its width corresponding to the x-axis. So we're looking at the width of these boxes here of the mosaic blot is greater than the width of high school A. So again, look at the width for high school B for large bottles and then compared to high school A. Clearly, the width for high school B is greater than high school A. And so that is my response to that question. Moving on to FRQ question number 3. You can pause the video if you want to read the whole question, but my response to question 3 part A, this is an observational study because no treatments were randomly assigned to the models of cars. So this is definitely not an experimental design. Only the mileage of each models were measured or observed by asking the owners of each model of car for their mileage estimate. Again, no treatments were assigned, so this is an observational study. Now moving on to this question, we need to describe a method to assign two treatments that James is planning to do. One treatment being autopilot feature and the other treatment is no autopilot feature. So I said first label the 70 different days from 1 to 70. Use a random number generator to generate 35 unique and valid numbers from 1 to 70. And what I mean by unique is basically ignore numbers that have already been generated. And then assign the days corresponding to the 35 generated numbers with the treatment, which is for using autopilot feature, and assign the remaining 35 days to the treatment for no autopilot feature. So this question is asking how can James be able to generalize to all Model D cars in the club, and what he needs to do is to randomly select Model D cars from all the Model D cars in the club. Basically, what I'm saying is you need to randomly sample in order to generalize to a population. All right, moving on to FRQ question number 4. So for part A, we need for question 4A, the first part, we need to calculate the mean of the distribution of the number of geodes 0 open until a red crystal is found. So here we're just basically using the formula that on the formula sheet. And remember, this is a geometric. We're dealing with a geometric distribution here. So if you look back at the equation or the formulas that College Board has provided us, see for geometric distribution, mu is 1 over p, and standard deviation is square root of 1 minus p over p. So we can simply plug in our given values. So p is 0.08, as stated here. The probability that geo contains a red crystal is 0.08. So do 1 over 0.08, that gives us 12.5 geodes. For this part, for the standard deviation, again we plug in 0.08, and that gives us 11.99, which is approximately 12. So moving on to this question, calculate probability of y equals 3. I use my calculator, in this case, the geometric PDF function. Again, there's a lot of ways to do this question. There's actually a formula for this, but for simplicity's sake, I just use the geometric PDF function on my calculator. Again, you have to define what values you plugged in. P probability is 0.08, and as you see, seeing when y equals 3, on the calculator it has an x. But anyways, it's the same thing. It will give us 0.067712. Then calculate the probability of y equals 4. So remember, for a distribution, right? For probability distribution, all the probabilities have to add up to 1. So since we have the first 3 already, third one, which is already calculated here, 0.067712, we can add all the probabilities that we already have right here, as you see here, and then we can do 1 minus the sum of all these probabilities that we already have, and that should give us 0.778688. And in order to calculate the mean of the distribution number of geodes Conrad would open, you simply just do 1 times 0.08 plus 2 times 0.0736, 3 times 0.67712, and then 4 times 0.778688. And that should give you 3.545 geodes. And the meaning of this value is basically if Conrad decides to play the game and stops opening geodes after finding a red crystal, or when 4 geodes have been opened, and Conrad does that many times, Conrad will open on average around 3.545 geodes. It's important that you say many times. Move on to FRQ question number 5. Part A, basically it's asking us what is the probability that the collector has been collecting baseball cards for 11 or more months. 11 or more months, so we're talking from this column to and 11 or greater than that. Okay, and then and has a majority of regular baseball cards. So here I just basically added 71 over 500 plus 76 over 500 plus 112 plus over 500. That gives us 0.518. The next problem is asking us what is the probability of collecting baseball cards for fewer, or for selecting a collector from the sample that has been collecting baseball cards for fewer than 6 months. Given that, what is the probability the collector has a majority of regular baseball cards? So given fewer than 6 months, so we're looking at this column right here. So the total for this column is 91. And we're looking at a majority of regular baseball cards, so it would be 80 over 91, and that gives us 0.879. So Michelle believes that there is a relationship between the number of months spent collecting baseball cards and the type of card that is majority in the collection. So the hypothesis test for this investigation would be a chi-square test for independence, and that's because we are comparing distributions. And it's not a chi-square test of homogeneity because we are not getting our samples from 2 populations. We are only getting our sample from 1 population, which is all the baseball card collectors at a convention. So it's a chi-square test for independence. And we're going to state our hypothesis here. Our null hypothesis is that there is no relationship between the number of months spent collecting baseball cards and which type of card is the majority in the collection. The alternate hypothesis is that there is a relationship between the number of months spent collecting baseball cards and which type of card is the majority in the collection. And so here it gives us a p-value of 0.0075. And we can conclude that since p-value equals 0.0075 is less than the alpha value 0.05, we can say that the alternate hypothesis is rejected. There is convincing evidence that there is a relationship between the number of months spent collecting baseball cards and which type of card is the majority in the collection. And moving on to the final FRQ question, question number 6. Again, pause the video if you want to read the whole question. So the answer to the first part of question 6, we will be doing a 1 sample t interval for mu, and mu, which is our parameter, is the true mean price in dollars of this type of whistle at all stores that sell the whistle. Okay, so we're given a sample distribution here. So the shape of the distribution of the sample right here is skewed right. Again, when you're determining if it's skewed left or right, it always chases the tail, and the tail's to the right, so it will be skewed right. And evidence from the summary statistics table, one evidence is that the distance between quartile 3 and the maxima is 1.105, which is much greater than the distance between quartile 1 and the minimum, which is 0.26. Now, there's a lot of ways to justify this based on a summary statistics table, but this is just one way. And here we are determining if there are any outliers using 1.5 times IQR rule. So the IQR is quartile 3 minus quartile 1, which is 0.965. Again, we have all these values on this table. And then we do the IQR, we do the 1.5 times IQR rule, and that gives us 1.4475. So basically, we can add this to quartile 3, and that gives us 6.9225. Or we can do 4.51 minus 1.447, 4.51 being our quartile 1, that gives us 3.0625. And that basically tells us that if there are values outside the interval 3.0625 to 6.9225, then there are outliers. But looking at the summary statistics table, the minimum is only 4.25 and the maximum is 6.58. And again, you can confirm that by looking at the sample distribution that they've given us. But basically, there are no outliers because all the sample prices are within 3.065 to 6.9225 dollars. This question is asking us to calculate Pearson's coefficient of skewness, so we simply plug in the given values. X bar is the mean right here for here, so 5.12. M is sample median, again it's given us 4.85. And then S is sample standard deviation to 0.743. Plug all those values in into the given formula, and that gives us 0.949. This is asking us to indicate the value of the Pearson's coefficient of skewness for the appropriate sample size on this graph. So the sample size is 20 right here. And so we can start here, sample size 20, and we calculated 0.949. So 0.949 is around here, so the x should be around here. And looking at this graph, we can conclude that the shape of the distribution is skewed right because the Pearson's coefficient of skewness of 0.949 for sample size of 20, which we have marked as an x here, is not within the shaded region. So clearly you can see that it's not within this shaded region according to the graph. So the distribution of the sample of whistle prices is considered strongly skewed. And you can see that in the region that is not shaded, it says the distribution of sample data is considered strongly skewed. And lastly, this question is asking if we meet the conditions for normality. We do not meet it because the sample size of 20 is less than 30. So here the first one is already not met. Oopsies. But then, oh, where did everything go? Oh, there we go. And then, lastly, the second part of this condition, since it's less than 30, it doesn't meet this condition because, as you see according to the graph, our sample data is strongly skewed, so it does not meet the second part of this condition. So ultimately, we do not meet the normality condition. And that is it for the 2024 AP Statistics FRQ section. In my opinion, I thought that this FRQ was pretty fair. It was not too difficult. So please let me know if you have any different answers or responses to what I have. And also leave a comment of how you thought this FRQ was. And so, yeah, thank you for listening, and I'll see you later.